Hi, my name's Alex Corbett. I am a senior lecturer in the biophysics group at the University of Exeter, and the purpose of this short video is to illustrate how to capture point spread functions on a confocal microscope using the PSFcheck slide. Demonstrating this for me will be Corin Liddle, who's an experimental officer of light microscopy at the University of Exeter Bioimaging Centre. We'll be imaging the PSFcheck slide on a Leica TCS5 confocal. The first step is to remove the PSFcheck slide from the box. The sample will be on the same side as the label. The slide itself is composed of a polymer disc located between two ring-shaped spacers. I always recommend cleaning your PSFcheck slide before use. Here we are using a solution of 70% propanol. Next, place the PSFcheck slide on the stage with the label facing towards the objective lens. Once centered on the polymer sample, patterns can be located using a 10x air objective in bright field illumination. Once illuminated, the patterns can be centered, focused and rotated using the microscope controls. This bright field view shows all 5 patterns on the PSFcheck slide. First is a single point power series, which contains the sub-resolution features we're going to be using to measure our point spread function. Second, we have the large and small 3D point arrays. On the left, we have a 500 micron square grid. On the right, we have the large area power series with bars of varying brightness. Once we have the pattern in focus, we can now switch to a higher NA objective lens for fluorescence imaging. Here we apply the immersion oil recommended by the manufacturer to the 1.4 NA objective lens. The PSFcheck slide patterns are fluorescent across the visible range of excitation wavelengths, and here we are illuminating with 488 nanometers at a 20% power. We start by focusing on the grid, which is at the same depth as the shallowest layer of the 3D point arrays and at the same depth as the single point power series. After locating the 3D point arrays, you can then move 10 microns into the sample using the bounding boxes as a guide to navigate your way to the single point power series that we saw illustrated in the bright field picture. Don't forget that the single point power series is 10 microns shallower than the bounding boxes for the 3D point arrays. Once you have the single point power series in focus, you'll see that the point sizes get smaller towards the base of the pattern. The sub-resolution features are in the penultimate row. Whilst all of the features in the penultimate row are sub-resolution, there will be some variation in the absolute brightness. Here we zoom into 3 sub-resolution features in the centre of the field. Next, we create a Z-scan of 4 microns total depth, 2 microns either side of focus in 0.3 micron Z steps. We sample the image at 1024 by 1024 pixels, 200 Hz acquisition rate and 4 times line averaging. Once all the settings are completed, we acquire a Z-stack, taking less than 5 minutes. After acquisition, we clean the slide and oil objective and can move on to analysing the acquired PSFs using freely available software such as PyCal. Thank you for joining me on this whistle-stop tour of acquiring point spread functions using the PSFcheck slide. I hope you found it useful.